Hello there, Mr. Sutton bringing you the MCAS 2008 solutions. For number one, we want to know which of the following equations is true. So what I would do here is, first off, I see that I have 7 times quantity 2 plus 3 on the left side of all these equations. So let's figure out what that equals. That's really going to be, let's see, following PEMDAS 7 times 5, because we have to do parentheses before multiplication. So 7 times 5 is 35. And now we're just looking for any of these that equals 35. Well, here we've got 3 plus 14, which is not 35, it's 17. Here we've got 7 plus 6. Again, parentheses always happens first, and that's going to be 13. Here we've got 3 times 9, which is 27. And here we have 7 times, well, this is also 5, so that's going to be 35 there. So choice D is the one that makes the most sense, and you could have actually saved yourself a little time just realizing that addition is commutative. Changing the order that I'm adding 2 and 3 in is not going to change the answer. For number 2, we want to know which of the following is closest to the value of cube root of 120, and keep in mind this is the no calculator section. So what I'm going to do here is pick 2 perfect cubes that 120 is between. And looking at my numbers here, I have some candidates. So 4 cubed is 64, and then the next one, 5 cubed, that's 125. And 120 just so happens to be between 64 and 125. Therefore, the cube root of 120 is between the cube roots of those numbers. So what we're basically saying here is 120 cube root has to be between 4 and 5. Well, those are both answer choices, so how do we pick one of them? I'm just going to pick the one that we're closer to. We are much closer to 125 than we are to 64. Therefore, that means that the cube root of 120 has to be closer to 5 than it is to 4. And they said pick the closest, so we're going with 5. For number 3, we have this cylinder with the following dimensions. We want to know the volume in cubic centimeters of this container. So volume for a cylinder, that's off your formula sheet. In general, that's going to be pi r squared times h. It's just the area of the circle multiplied by the height. So in this case, we got to pick out our parameters carefully. The radius is going to be half the distance across, so half of this 8, which is 4. And then our h value, our height, is going to be 10. So we have pi times 4 squared times 10. That's really just, let's see, 16 times 10 is 160 times pi. And that's actually one of the answer choices, 160 pi, so choice B. For number 4, they want to know which expression is equivalent to p minus 4 times p plus 2. So this is one where you just have to FOIL it out and combine like terms. So we've got the first, that's going to be p squared. Outers will be plus 2p. Inners is minus 4p. And then the last, minus 4 times 2, is going to be negative 8. Now we have to combine like terms. 2p minus 4p, that's going to be a negative 2p in the middle. Nothing else can get combined, so that leaves us with choice A. For number 5, we want to know which of the following values below is a solution of x squared equals 256. So the most direct way to solve this equation is just square root both sides, remembering that you have a positive negative root when you square root equations. So this is plus or minus square root of 256. And what is the square root of 256? Again, this is the no calculator section. Well, let's look at our answer choices. Square root of what would be 4? Well, that would be the square root of 16, so that's definitely not it. Could the square root of 256 be 16? It sure could. Could it be 128? No way, Jose. So definitely it's going to be negative 16 then. This is going to be actually plus or minus 16, which lets us choose answer choice B. For number 6, a waiter receives a 15% tip for a restaurant bill of $59.14. Which of the following estimates is closest to the tip? So I'm going to set up a proportion to solve this. I've got 15 over 100 for 100% equals part over whole. So whatever the tip was, I'll call it X over whatever the original bill was. But now since I'm estimating this, I don't have to use 59.14. I'm going to use 60 instead. So my setup, I'm going to do 15 over 100 equals x over 60. And there's other ways to do this problem, but this is the most kind of mathematical formulaic here. So I'm going to have to cross multiply to solve for x. Before I do that, though, since this is not the calculator part of the test, I'm going to reduce 15 over 100. that's really 3 over 20. And now that's a lot easier to work with. Cross multiplying, I've got 20x equals 180, 3 times 60. Dividing both sides by 20, I've got x equals 9, so $9, which is answer choice C. For number 7, the weight in pounds of 7 packages is listed below. So we have all 7 here. And now the weight of an 8th package is added to this list. The mean weight of the 8 packages is 12 pounds. We want to know the weight in pounds of that 8th package. So in general, the mean is going to be the sum of all these packages divided by the number of packages. That's how you calculate an average. So how can we express all these things? Well, we actually already know the mean, right? They told us it was 12 pounds. So we can plug in something for that right away. And now the total weight, we almost know that. We know the weights of all of these. So if we add all these together and add one more on the end, I'll call it x, then that'll be the total weight. The number of packages we know, they told us that was 8. So writing all this out, I've got 12 for the mean. I have all my packages added together, all 7 of them, plus that mystery 8th package's weight, and then dividing by 8 packages. All right, so this is just a regular equation now. To make my life a little easier, I'm going to add all the stuff together up there. And again, this is the no calculator section, so be careful doing this. So I've got 25 plus, we got another 30, that's 55, plus another 10 here is 65, 68, 77. So we have 77 plus x. And one other thing I'm going to do to make my life a little easier, I'm going to multiply both sides by 8 to get rid of this 8 down here. So 8 times 12 gives me 96. So when the dust settles, I've got 96 equals, all these combined was 77 plus x. Now I just have to subtract 77 to solve for x, and that's going to give me 19. So 19 pounds, choice A. For number 8, point S is the midpoint of segment RT, and the coordinates of R and T are given below. So R was negative 11, negative 12, T was negative 7, negative 4. Based off of this, we want to know the coordinates of point S. So basically, they're asking for the midpoint of these 2 points right here. So in general, the midpoint formula is going to be this one right here, x1 plus x2 over 2 and y1 plus y2 over 2. Basically, you're just averaging the x values together and averaging the y values together. So let's just set that up. We're going to have negative 11 plus negative 7 over 2 and negative 12 plus negative 4 over 2. So that'll be negative 18 over 2 and negative 16 over 2, which I can reduce to negative 9, negative 8, which gives me answer choice C. For number 9, we want to know which of the following is equivalent to x squared minus 144. So this is basically asking if you know certain factoring shortcuts. This is the shortcut a squared minus b squared equals a plus b and a minus b. Essentially, you just square root both of these and stick them together with a plus and a minus in parentheses. So the square root then of x squared is just x. Square root of 144 is 12. So we have x plus 12 and x minus 12. And they wrote them in reverse order here, but it's the same thing. So that'll be choice D. For number 10, we have a rug in the shape of a square with an area of 33 square feet. Which of the following estimates is closest to the length of each side of the rug? So for this, we'll use our area formula for a square, a equals s squared. And we can actually plug in a number here. We were told that the area was 33. So that means that to get the side of the square, we have to square root 33. And we don't need a plus or minus because we're actually finding real dimensions, not negative sides. So we know that s is going to be the square root of 33. Of course, that's none of the answers. We have to estimate this without a calculator. So we're going to do our little comparison trick where we try to figure out what this is between. So I know that this is between the perfect squares 25 and 36. And I know that the square roots of those are 5 and 6. So square root of 33 is between those two numbers. But which one is it closer to? Well, 33 is closer to 36, so that means the square root of 33 is most likely closer to 6 than it is to 5. So what answer choice is closest to 6, but also a little bit less than 6? So taking a look here, I've got 5 and 1/4. 5 and 3/4 is even better. and then we're going over with these other answers, so it's going to have to be choice B. For number 11, we have a scatter plot given below here, and we want to know which of the following equations best represents the line of fit for the data in the scatter plot. So with line of fit, you're basically just trying to draw a line that goes as close as possible to all of these dots. So just trying to minimize the distance between the line and each of these. So I'll just draw one such line here. And there might be a little bit of debate whether, I should be tilted up or down a little bit, but this is at least a starting point. If we need to get more accurate, then we'll do that. But let's look at the answer choices before we start panicking. Looking at our answer choices. So we have two answer choices with a negative slope, which cannot possibly be the answer because this is definitely a positive slope. So that gives us answer choices C or D. Now between the two of these, they're both with a slope of 1/2, which is exactly what my line just happens to be. I'm just that good, I guess. But now they have a different y-intercept. This is a -2 versus a +1. Looking at what I drew here, this is definitely going through +1. It's definitely got to be above the x-axis. So that would mean then that answer choice D is my best bet. So in general, using y = mx plus b reasoning, my line had a slope of 1/2 and a b value of 1. So that's going to be answer choice D. For number 12, we have a parallelogram, and the area of this parallelogram, they're telling us, is 90 square inches. Based off of that, they want to know this missing h value, the height of the parallelogram. So for this, you just need to know that the area of a parallelogram is base times height. It's just the same as a rectangle. The fact that it's slanted like this actually doesn't make any difference, and we're not going to take the time to prove it, but it's true. So now let's just plug in what they gave us. They told us the area was 90, so A is 90. The base is just this side here, that's 15, and h is what we're looking for. Solving for h, we just have to divide both sides by 15. 90 divided by 15 gives us 6. So that's going to give us choice A. For number 13, they want to know which of these expressions is equivalent to 17, and you're not allowed to use a calculator to plug any of these in. Now, if you look at all these, we're doing various things with 17 and the number 3. Here we're multiplying and cube rooting. Here we're basically dividing by 3 and cube rooting. Here we're cubing and cube rooting. And then down here, now we're cube rooting and then dividing by 3. So we've got all these 3's going on. We're basically asking where are these 3's going to cancel out. And the only opposite pair of operations in here is this cube root and this cube that are going to cancel each other out. So that means choice C is the only one that makes sense here. For number 14, we have two groups going on a trip to a theater. First group has 30 students and 4 adult chaperones. Second has 25 students and 4 adult chaperones. And the cost for each of these can be determined using this system of equations below. So let's see. Apparently, with the 30 students and the 4 adults, it was $720 and $620 for the other group. Based off of this system, we want to know the cost of each student ticket. So the key on here, there's a lot of different ways you can solve the systems of equations. We've got elimination, we've got substitution. I notice here that I've got 4a in both of these, and it's already lined up in standard form here. So if I were just to subtract this bottom equation from the top equation, that would immediately cancel out these a's, leaving me with only one variable. And it actually happens to be the variable I want. I want the cost of student tickets, so eventually I have to solve for s. So let's go ahead and enact that plan. I'm going to subtract this equation from the top equation. And if you're not used to subtracting equations, you could just multiply this whole second equation by -1 and then add it to the other equation. Either way, going through here, we've got 30s minus 25s, which is 5s. The 4a's cancel out, and here 720 minus 620 is 100. Well, this couldn't be nicer, right? Just divide both sides by 5, and we have a student ticket costing $20. So that's going to be choice B. For number 15, they want the value of this expression. No multiple choice this time. This is just a straightforward PEMDAS kind of problem. So let's just follow the order of operations. First thing that happens is parentheses. So I look inside my parentheses. I've got to do all this stuff first before I multiply by -2. Unless I want to distribute the -2, but that seems like a lot of work. So inside here now, what happens first? Well, exponents are the next in our list, so this 3 squared has to get done. That's going to be 9, so we have 9 minus 10 inside. And we still have to finish out that parentheses, so 9 minus 10 is negative 1. Negative 2 times negative 1 is 2. For number 16, we have a line plot showing the number of red items of clothing owned by each student in the class. We want to know basically the median number of red items of clothing owned by students in the class. And the way this is set up, this basically means that we have 4 students who own 7 red items. Oh, here's a student who owns 11 red items. Must really like red. So we need the median out of all this. To do that, you could write out all these numbers in order, or you can just use the cross-off method directly on the line plot. I'm going to do that second approach. So I'm going to cross off the ends and then work my way to the middle. So here's one set of endpoints crossed off, and then I'll do this lower x and this x. It doesn't really matter which of these you did, though. Here's the other x and this 9 over here. This 5 is going to cancel out this 8. Another 5 cancels out one of the 7s. We have a 6 and a 7 canceling, another 6 and another 7, and that leaves us with a 6 and a 7 when all is said and done. Now, the rule is if you have 2 items in the middle after you cross everything else off, you have to average them together to get the true median. So our median then is going to be 6 plus 7 divided by 2, which we can do without a calculator. That's just 13 over 2, or 6.5. For number 17, Stacy's going to paint the 4 walls of a room. 2 walls each have a length of 20 feet. Other 2 walls have a length of 16 feet. The expression below represents the total perimeter in feet of the room. Hey, we're not even going to make you work to figure out how to find the perimeter. Here it is. Based off of this, for part A, we want the total perimeter of the room. So they're basically just asking you to evaluate this. This is just PEMDAS. So we'll do the parentheses first. 20 plus 16 is 36. So 2 times 36 then gives us a perimeter of 72 feet. For the next part of the problem, the room has 2 windows and 3 doors. Each window is 4 feet and 3 feet wide, and then each door is 7 feet high and 3 feet wide. Here's an expression for the total area of the windows and doors in the room. All this stuff. We want the total area of the room, of the windows and the doors in the room. So basically, again, just using PEMDAS to evaluate this. Nice. Let's do parentheses first. We don't really have to because we've got multiplication, all multiplication here and over here, but hey, why not? So we've got 2 times 12 plus 3 times 21. That's going to be 24 plus 63, because we have to do multiplying before adding, M before A in PEMDAS. And then 24 plus 63 comes out to, let's see, that's 87. So that's 87 square feet, because we're doing area now. For this next part, the height of each of the walls is 6 feet. Stacy's not going to paint the windows or the doors. And here's an expression representing the total area that Stacy's actually going to paint. So it looks like here we have an expression for the area of the walls minus all the areas of the doors and the windows. Now, we want to know the total area that Stacy's going to paint. Basically, again, you just have to evaluate the expression. The good news on this one is all this stuff that we're subtracting, this should look familiar because we actually just figured this out in part B. So we figured out that was 87. So I'm just going to rewrite this a little bit to be all of this stuff in the beginning minus 87 from part B. All right, so we don't have to do all that over again. Let's just take care of this front part here. So again, PEMDAS will do the parentheses first. Within the parentheses, multiplication is happening before addition. So we've got 160 plus whatever 16 times 8 is. Let's see, 8 times 10 would be 80, plus 8 times 6 would be 48, so that's 128 altogether. And then 160 plus 128 gives us, let's see, that would be 288. Now we have to multiply that by 2. So let's see, that's 400 plus another 160 plus another 16. So that's going to be 576. And then we'll subtract 87 from that. So if I subtracted 80, I mean, I could do this with long arithmetic, but you can do that if you want. That would be, let's see, 576 minus 80 would be 496 minus another 7 would be 489. So I'm just doing it in pieces here, and that is in square feet. For part D on this question, there's a little bit of a backstory. Each gallon of paint covers a total area of 300 square feet, and Stacy wants to do 2 layers of paint. So here's the expression they're just kind of giving us for the total number of gallons that Stacy needs to paint the room with 2 layers. We're also told that each gallon costs $26. Stacy has to purchase full gallons of paint, so we can't have a fraction of a gallon of paint, unfortunately. So we want to know the total cost in dollars of gallons of paint Stacy needs to purchase to paint the room. All right, so there's a lot going on here. We need to, so this is just the gallons of paint. This whole expression is just giving us gallons of paint. When we get that number, whatever it is, we need to multiply that by 26 to find out the actual price of all these gallons of paint. So we're going to do 26 times all of this stuff. Now, there is some good news. If you look at this expression here, we've got 2 times and then all of this stuff inside a big curly bracket. They needed 3 different flavors of parentheses for this mess. All this stuff inside the curly braces here is actually just what you did in Part C. If we take a look back at Part C, all of this stuff here, we saw that all came out to 489. So I'm just going to call this 26 times 2 times 489 over 300. And again, this 489 piece, that was what all that craziness inside came out to from Part C. All right, moving on now. So that was the first hurdle on this. We've saved quite a bit of time not having to do that over again. But now we run into a little bit of a problem because we're clearly going to run into some kind of fraction, right? 300 does not go into any of this stuff evenly. But we can't get fractions of a gallon of paint. We have to get full gallons of paint. So that means we need to tweak this a little bit so that we end up with a nice whole number, the smallest whole number possible out of this. So how are we going to do that? Well, if I multiply 2 times 489, I don't know exactly what it comes out to, and I don't care, but it's going to be a little bit less than 1,000 and more than 900. Since it's more than 900, I want to round whatever this comes out to up to the next multiple of 300. What's the next multiple of 300 after 900? Oh, 1,200. So I'm going to call this 26 times 1,200 over 300. And now, if I do 1,200 over 300, that comes out to the nice, neat number of 4. And if I do 4 times 26, that's going to be a little bit more than 4 times 25, so $104. For number 18, we've got these 2 similar rectangles with the following dimensions, and we want to figure out the value of x right here. Well, since these rectangles are similar, they told us they're similar, we can just set up a proportion and solve for x. So we could write this in a few ways. The way I chose to do it was 5 over 10 equals x over 12, and that's one way to do it. You also could have done it 5 over x equals 10 over 12, either way. So now going ahead and cross-multiplying here, actually, if I wanted to, I could reduce this to 1/2, and that would be even easier, but I can handle this if I don't reduce first. So we've got 10x equals, this will be 60, and then that's just going to be x equals 6 inches. Make sure you have the units in there, because this is a free response problem here. For number 19, the equation below here has 2 solutions. That was nice of them to tell us. One solution is -3. What's the other solution of the equation? So -3 is what you would have gotten if you just said n plus 4 equals 1 just by dropping the absolute value, and then subtracting 4 from both sides would give us -3. To get the other solution, you have to set n plus 4 equal to -1. And the reason we have to do this, if the stuff inside here has a value of -1, then the absolute value of that -1 would also be 1. All right, so subtracting 4 from both sides, we end up with n equals -5. For number 20, Lionel wrote an arithmetic sequence. Here are the first 5 terms. For part A, we want to know the next term of Lionel's sequence. She'll explain how he got the answer. So since it's arithmetic, that already tells us that we're just adding the same thing over and over again, which you can see by looking at the pattern here. So what are we adding to get the next number? Well, you can just look at one number minus the term before it. So 10 minus 3, for example, would be 7, and that's consistent throughout here. Since we're just adding 7 each time, to get the next term, we just have to do 31 plus 7, which comes out to 38. For part B, we want to know an expression that can be used to find the nth term of Lionel's sequence. So for this, I'm going to use my nth term formula, where I start with the first term. That's a sub n equals a sub 1 plus d times n minus 1. Basically just a fancy version of slope-intercept, where this is your starting value and this is your slope. But we do n minus 1 because we've already used up the first term with this a1 term right here. Okay, so my first term is going to be 3. And then for my d value, well, that's just what I'm adding each time to get the next number. That's 7. So we have 3 plus 7 times n minus 1. And this is an expression that you could use to find the nth term. They didn't say it had to be in a specific form, so this should actually be good enough. But if you want, you can reduce this or simplify it. So we would have 3 plus 7n minus 7, and then adding 3 and negative 7, that would be a negative 4 that you could reduce this to. So negative 4 plus 7n would also be an expression that works. For part C, we have someone else in the story now. Bella wrote an arithmetic sequence. Each term of Bella's sequence is equal to 3 times the corresponding term of Lionel's sequence. So we want an expression that can be used to find the nth term of Bella's sequence, although they called it the mth term here. So my reasoning on this one, since each term is being multiplied by 3, that means our first term is now 3 times 3, or 9. So that'll be the a sub 1 in our formula. And also, what's the common difference looking like on these? Well, you're no longer going from 3 to 10. You're going from 9 to 30. So your common difference also has to get multiplied by 3. So 3 times 7 gives us a common difference, now a d value of 21. Plugging all that in, I'm going to write b for Bella sub m, because they said the mth term, not the nth term. That's kind of a picky distinction. B sub m equals first term of 9 plus common difference of 21 times, and I'll call that m minus 1. There we go. So that's one formula that would work. You could also distribute the 21 and simplify it. So that would be 21m minus 21 plus the 9, so minus 12 plus 21m. For part D, we want to know the 20th term of Bella's sequence. So we're going to take what we got for Bella's formula, which was, again, 9 plus 21 times n minus 1, and just plug 20 in for m. So now we've got 9 plus 21 times 20 minus 1. Now this is a non-calculator section, so you could make this 19 and then multiply it out by hand. I just chose to distribute 21 to both of these, like so. So I've got 21 times 20, which is 420, minus 21. This gives us 429 minus 21, which is 408. For number 21, we have a company packaging fruit baskets of different weights and shipping them to customers. Company charges a flat fee for packaging the baskets. The total packaging and shipping cost in dollars Y of a fruit basket weighing X pounds is represented by the line on the graph below. So this is a 6-part problem. Usually they don't have that many, but this one is parts A through F. So we want to know, first off, for part A, what is the y-intercept of the line on the graph? Well, this is the place where you're touching the y-axis, where x equals 0. So that's just going to be 4. For part B, they want to know, what does the y-intercept of the line represent in this situation? So the x values here, the x-axis, this is the weight of your basket. So at 0 pounds, then, the price of packaging and shipping is $4. But it'd be kind of silly to say that it costs $4 to ship a 0-pound fruit basket. So what does this 4 really mean? Well, this is the price before we've added in any poundage for shipping. So this is just what you must have been paying for the packaging. Remember up here they said we're charging a flat fee for packaging. So that flat fee must be this $4. And then everything that comes after that is all shipping. So we'll say flat fee for packaging the baskets before shipping weight is applied. For C, we want to know the slope of the line on the graph and explain how we got the answer. So we can just do y2 minus y1 over x2 minus x1, change in y over change in x. But which x and y value should we use? Well, this graph appears to go through a lot of different corner grid lines, so we have a lot of choices, but they actually gave us these 2 points here. So just to be on the very safe side, I'm going to use 3,10 and 6,16. But it turns out anything else that looks like it's on this line does actually work on this problem. So we're going to have 16 minus 10 for our numerator and 6 minus 3 for the denominator, delta y over delta x. So that's 6 over 3, which comes out to 2. For part D, we want to know what the slope of the line represents in this situation. So let's look at our units here. On the x-axis, we have pounds. So for every additional pound, we're adding on dollars as the y values here. So our slope of 2 means that for every extra pound you add, you're getting an additional $2 to the price. So we'll say that the slope is how much the price goes up, $2 for each additional pound. For part E, write an equation that represents the line on the graph. So this looks like a good candidate for y equals mx plus b because we have the slope and we have the y-intercept. They actually made us find those earlier on. So our slope, remember, was 2. The y-intercept, that was the very first thing we found in part A. That was 4. So we can write then that y equals 2x plus 4. And now for part F rather, use the equation we wrote in part E to determine the weight in pounds of the heaviest fruit basket that could be packaged and shipped for $50. Explain how you got your answer. So $50, that's the output of the equation that we just wrote. That's the y value. We want to know the x value, the input, the pounds that would give us that. So I'm just going to write 50 equals 2x plus 4. Just plug in 50 in for the y value in our equation. And now we just solve for x. So subtract 4, we've got 46, divide by 2, and we have an x value of 23 pounds. That is an awful lot of fruit. For number 22, we have Rasha and Scott going to a bakery. Rasha buys 4 plain bagels and 2 chocolate donuts for $8.70. Scott buys 3 chocolate donuts for $2.55. We want to know the cost of 1 plain bagel at the bakery. So this is a system of equations kind of situation here. We have multiple takes on roughly the same information. So we're going to set up an equation for Rasha's purchase, one for Scott's, and see if we can use those together to figure out the price of a bagel. So let's start with Rasha. I'm going to let P represent the plain bagels and C represent chocolate donuts. So we can here write 4P plus 2C equals 8.7. And now we need one for Scott. Now Scott's is a little bit simpler because he didn't buy any bagels, he just bought donuts. So we can just write 3C equals 255. All right, let's go ahead and solve this now. Now this is actually a pretty easy system of equations because we already have a variable all by itself, or pretty close to by itself, in one of these equations. So we can just solve for C right away by dividing 2.55 by 3, which I will do on the calculator. So there we go, 255 over 3 gives us 85 cents for a chocolate donut. And now we're going to use that to figure out the price of a bagel. So we're going to plug 0.85 in for C in Rasha's equation up here. So we can write 4P plus 2 times 0.85 equals 870. And let's see, I know this off the top of my head. This is $1.70. So let's just subtract 1.7 from both sides, conveniently giving us 4P equals $7. And let's see, what's $7 divided by 4? Well, let's see here. I know that $6 divided by 4 would be $1.50, so that's an extra quarter for each of those bagels. So $1.75 overall, which gives us answer choice C. For number 23, we have the first term of an arithmetic sequence being 5, and the third term is 13. Which of the following represents the nth term of the sequence? Now, this is one of those problems where you could just plug in 1 and 3 for each of these answer choices and see which ones gives you 5 and 13. But we're going to be a little more sophisticated than that and actually come up with the equation the long way here, just in case you're wondering. So we're going to need a common difference in order to write this. To get the common difference, normally you would take one term and subtract the term before it, but they didn't give you consecutive terms here. They gave you the first and the third term, not the first and the second term. So another way of figuring out the common difference is essentially to find the slope between these two terms. So we're going to do the change in outputs minus the change in inputs. So that would be 13 minus 5 over 3 minus 1 because of third and first term. And that ends up giving us, let's see, 8 over 2, which is 4. Now just to do a quick check, if I add 4 once, that gives me 9. 9 would be the second term. Adding 4 again gives me 13, the third term. Great. Let's keep going now. So in general, for the nth term, you have the first term plus the d times n minus 1. First term they did give us, that was 5. So we can write 5 plus 4, parentheses, n minus 1. And that, of course, matches none of the answer choices because they always simplify these. So let's distribute that 4. That's 4n minus 4. And now combining the 5 and the negative 4, we end up with 1 plus 4n, or you could also call this 4n plus 1, which would give you answer choice A. For number 24, we have a quadrilateral graphed in the grid below. And they're saying that this quadrilateral is going to be reflected over the y-axis and translated 4 units down. They want the coordinate of the image of point S after these transformations. So there's a few ways to do transformations. You could actually do it all algebraically. In this case, to reflect over the y-axis, you would have to negate all the x values, and then to translate it 4 units down, you would have to subtract 4 from all the y values. That's one way to do it. Another way, since they actually gave you the shape in the grid, is just to do it visually. So if we have to do a reflection over the y-axis, now and we're only doing this for point S, here's S, so reflect that over the y-axis. We're 5 away from the y-axis to the right, so we're going to walk 5 away from the y-axis to the left. And I'm going to call this S prime. This is the first transformation on S. Now that's not enough though. They wanted us to translate that 4 units down, so I'm going to walk 4 units down from S prime down to here to give me S double prime. So that's the point I'm actually looking for. That's one of my answer choices. What point is that? Well, this is negative 5 comma negative 2. So that would give us answer choice A. For number 25, we have a box and whisker plot with distributions of numbers of calories per serving for a selection of breakfast cereals. Based on this plot, we want to know the median number of calories per serving for a cereal. So the median with a box and whisker plot is always the easiest thing to pick out. It's just the middle line. Median equals middle line. So the middle line is just this line right here, and that appears to have a value of 125, which gives us answer choice C. For 26, we have a cup right here in the shape of a cone, and we want to know the volume of that cup to the closest centimeter. So let's go ahead and use our formula for the volume of a cone. You could look that up on the formula sheet. That's going to be 1/3 pi r squared times height. It's basically just a third of a cylinder of the same height. And now the r value here, they actually gave that to us pretty much. That's 5 halfway across. Height is 10. So plug 5 in for r, 10 in for h. And this is the point where we just break out the calculator. So here we go. I'm going to do 1/3, and you could do 1 divided by 3. I'm going to do alpha y equals, though, to get my fancy fraction form. So now we got 1 over 3 times, I'm going to use my pi button here because I can. I've got a calculator, not afraid to use it. And then we have 5 squared times 10, all giving us a grand total of 261.799 and some change. That's going to round off to 262. Nothing else is even remotely close. And that's in cubic centimeters if you were wondering. So that gives us choice C. For 27, volume of a right circular cylinder is 1,696 cubic centimeters. Height is 15 centimeters. Which of the following is closest to the radius? So let's start with a volume formula. That's volume equals pi r squared times height. And they told us the volume. They said it was 1696. And the height they gave us was 15. So let's plug that in. All we have to do now is solve for r. So this is going to take a couple steps here. We're going to have to divide by everything that's not r squared. So we have to isolate r squared. So we'll divide 1696 by pi, and we'll also divide by 15. So we have r squared equals 1696 over 15 pi. Next, we're going to go ahead and square root both sides. And they let us use a calculator, so let's go ahead and use it. So doing this on the calculator, you got to be kind of careful. I'm going to do the square root of, and now I'm going to use alpha y equals to get my fancy fraction. This way I don't have to worry about doing parentheses. So we've got 1696. Down here we've got 15, and I'm going to do my pi button. There we go. And if you didn't have the fancy fraction form, you would need a parentheses around the 15 and the pi. Let's press enter now, and that comes out to almost 6. So 6 centimeters when all is said and done, choice B. For number 28, Melissa owns a catering company. Good for her. For lunch and dinner, she serves appetizers before meals. The number she serves is directly proportional to the number of guests. At lunch, she gives 3 apps per guest. At dinner, it's 5 apps per guest. When serving 22 guests, what's the difference between number of apps she serves for dinner and for lunch? So this is actually a pretty straightforward one. How about we just figure out how many appetizers she's going to serve 22 people at dinner, and then subtract the number she'll serve at lunch. So we know that we get 5 apps per guest at dinner, so that would be 5 times 22. At lunch, we would have 3 times 22, and then we just need the difference between these things. Now, I'm going to be super fancy. Even though this is the calculator section, I'm going to factor out a 22. That's right, we're going to go there. And that'll leave me with a 5 minus 3 inside parentheses. Well, we know what 5 minus 3 is. That's 2. And 2 times 22 is 44. Choice C. For number 29, we have a physician recording resting heart rate and also the average number of hours each person exercised. She wants to make a display of the data to help determine if the variables are associated. Which display here should she use? So this is where you got to know your data structures and what they're useful for. So we're looking for things that would help us determine if there's an association or relationship between two variables. Now, out of all of these, the scatter plot is really the best one for determining that. Scatter plot's great if you want to see if two variables are related, because as you might remember, we can do a line of regression. We can find the correlation coefficient using a scatter plot. It really just works best whenever you're trying to figure out what the relationship is, if any, between two sets of data. Now, these other ones, bar graph, circle graph, box and whisker plot, these are all good for like one set of data. And they're good for sorting things and seeing the distribution of the data, but they don't really tell you if two different things have a relationship. So scatter plot is the best answer on this one. For number 30, for all non-zero values of x, which of the following expressions has a value of 1? Now, in general, the shortcut on this problem is to realize that you get a value of 1 by multiplying something by its reciprocal. There's lots of other ways you could get 1, but all of these things have multiplication involved. Now, if you want to do it the long way, you can just go choice by choice and see what it multiplies out to. Now, remember, you're multiplying straight across, and you can cross-cancel when you do fractions. So this first one, this will be negative 16 over x squared, definitely not what we want. Here, we've got 4 over 4x squared, which we can reduce to 1 over x squared. Here, these x's cancel and the 4's cancel, but we still have a negative left over, so this is negative 1. Here, the 4's and the x's also cancel, but it's a positive, so this comes out to positive 1, which is what we were looking for, choice D. For 31, animal population doubles every month. The population begins with 20 animals, which expresses the animal population after 3 months. So we basically have to start with 20 and double 3 times. So multiply 20 by 2 3 times. How do we do that? Well, we would have 20 times 2 to the third power. We use exponents to multiply by the same number over and over again. So 20 times 2 to the third, that's answer choice A. Looking at B, they mixed up the 2 and the 3. C is not even close. 20 is getting the exponent. And here we don't have any exponents, so definitely choice A for this. For number 32, we've got this flagpole here. The base of the flagpole is 24 feet from some point on the ground. The flagpole itself is 18 feet. We want to know this distance here, the distance from the top of the flagpole to that point on the ground. So for this, we're going to use Pythagorean theorem. This is just a right triangle. So we've got 18 squared plus 24 squared equals x squared. And now we just need to square root 18 squared plus 24 squared. Now you could do all this on a calculator. You might also realize that if you divide both of these by 6, you've really got a 3 and a 4 here, which makes this a 3, 4, 5 triangle. 5 times 6 would be 30, which is what you'll get if you run these numbers on the calculator. So we end up with then 30 feet, choice C. For number 33, in a community college class, interquartile range of students' ages is 20 years, and the median student age is 30 years. Which of the following box and whiskers could represent the distribution of ages in the students in the class? So let's just do a little translation here. For 20 years, interquartile range, they're basically saying that the boxes have a combined distance of 20. It's a distance of 20 from the left of one box to the right side of the other. So that's going to narrow it down to, we got choice A, B is too small, C is too small. Choice D is also a distance of 20, from 20 to 40 here. All right, moving on. They also said the median student age was 30 years. So that means that the middle line in our boxes is going to be 30. So choice A, the middle line here is 35, so that's not right. Choice D, our middle line was 30, so choice D it is. For number 34, we have a right square pyramid that we're trying to find the volume of. So we'll use our formula here. V equals 1/3 s squared times h. And then the side they already gave us, that's 2.5. H is just the vertical height of the pyramid as opposed to the slant height, so that's going to be 4. And plugging all that in, let's just use the calculator and see what that comes out to. So just entering that in the calculator, and I used my fancy fraction form for 1/3 there. That was alpha y equals to get that. So press and enter. We got about 8.3, so that's roughly 8 cubic meters, which would give us answer choice C. For number 35, we've got Dietrich's budget here in circle chart form. We basically want to know if she spends $900 on food, how much does she spend on housing each month? So they didn't tell us the dollar amounts in here, they gave us the percentages, so we have to set up a proportion. So we're trying to relate food and housing. Well, we have the relationship between the percentages. We can write 30 over 45, and then we can set up a proportion with the money from food divided by the money from housing. So that would be 900 over, well, we don't know how much he spends on housing, so we'll call it X. So our proportion then, 30 over 45 equals 900 over X. And now we can just cross multiply. Actually, to make our lives a little easier, let's reduce 30 over 45 to 2/3. And now if we cross multiply, we've got 2x equaling 2,700. Dividing by 2, that's going to be $1,350. Choice D. For number 36, we've got an open response problem with a kite, as given in the diagram here, and some of the angles they gave to us. They also told us, although they didn't label the diagram with this, that the length of RS, that's this side here, is 20 centimeters. So we want to know what the length in centimeters is of PS. So the key on this one is that it's a kite. Since it's a kite, we know that this side, RS, and this side, PS, are going to be the same length. That's one of the properties of a kite, that your consecutive sides here are going to be congruent for two pairs of sides. Well, we already know what RS is. It's 20 centimeters, so PS must also be 20 centimeters. For number 36, part B, we want to know the length to the nearest tenth of a centimeter of ST, and then explain how we got it. So the key on this one is that we actually have a 30, 60, 90 triangle here, and you might remember the ratio, which is on your formula sheet. It's S root 3, and 2s, depending on what side you're across from. So I'm going to go ahead and label this triangle now, and then we can use this to figure out the length of ST. Now the key on this one is that they gave us RS right here. That was 20, they said. So let me label my sides now. The S side goes across from the 30-degree angle, so that's down here, this TR side. And then S root 3 is across from 60 degrees, so that's this side right here. And then the 2s is always the hypotenuse, so that's this 20 side over here. Now the key on this is you have to pick whichever side they gave you, the 20 in this case, and set it equal to whatever the s expression is, and then that'll let you find out what s is. So we can write 2s is equivalent to 20. So that means that s equals 10. And now we wanted to figure out st here, side st. So that's going to be equal to whatever s times radical 3 is. So in this case, because s is 10, st equals 10 radical 3. But now we have to look at the problem. They wanted this rounded to the nearest tenth of a centimeter, and radical form is not what they were looking for. So let's use the calculator to figure out what that should be. So just plugging in 10 radical 3 in my calculator, that comes out to 17.3, and that is in centimeters. For part C on this one, they want the length to the nearest tenth of a centimeter of TQ. So this is another 30, 60, 90 kind of situation here. Now, we know that from a problem 36 part B that this side over here had a length of 10, because that's what S was, and this was the S side on that last problem here. S was 10. So I'm going to put in from part B, TR equals 10, because we need one side of this triangle to find any of the other sides. And now I'm going to set up my ratio. My K, I'm not going to use S's this time because we already used S as a variable to find this other triangle's information. So I'm going to use K instead, but it's the same idea. So my K side is going to be across from 30. And then K radical 3, that's across from 60 degrees. So that's this 10 side is really K radical 3. And then my hypotenuse is going to be 2K. All right, so I'm going to set K root 3 equal to 10. That'll let me solve for the value of K, which is what I need here if I want to find TQ. It's the same thing as this K. And then dividing both sides by radical 3, I've got 10 over radical 3. And that's an issue because they wanted the nearest tenth of a centimeter. So again, we will use the calculator to figure out what that is. So 10 divided by the square root of 3 on a calculator comes out to 5.8. And again, that's in centimeters. For the last part of this problem, they want to know the perimeter to the nearest tenth of a centimeter of this kite. So basically, we have to figure out what all four of these sides are and just add them together. Now, the good news is we already know two of these right off the bat. They gave us this side in the beginning. That was 20, they said. And then we also found that this other side had to be the same thing. That was also 20. Now, these two sides down here, we actually almost have enough information to get them. We figured out in part C, if we go back to it here, let me just backtrack, that this TQ side, which is equivalent to K, we saw that that was really 10 over radical 3. So just going back here now, if that's 10 over radical 3, then this 2K side over here from part C has to be 2 times 10 over root 3, or 20 over root 3. And we know that this PQ side is congruent to QR, so that's also going to be 20 root 3. So at the end of the day, we're just doing 2 times 20 plus 2 times 20 over root 3. And for that, I will use the calculator because we've got these radicals and they wanted it rounded off. So here we go. I'm ready to plug this in the calculator. I've got 2 times 20, and I've got 2 times 20 over root 3. And again, if you're wondering where I get that fancy fraction from, alpha y equals, that'll let you get your menu of fraction formats. So pressing enter comes out to about 63.1, still centimeters, and there's our final answer. For number 37, if q is not equal to 0, which of the following is the additive inverse of the expression below? So additive inverse basically means opposite. It means whatever you add to this thing to cancel it out and get 0. So which of these things, if added to negative 2 over q, would give us 0? Well, how about positive 2 over q, right? So just choice D. For number 38, we have Howard running every day for an hour. First half hour, he runs at a rate of 10 minutes per mile. This is kind of a weird setup. Usually they talk about miles per hour or miles per minute. Here we're talking about how many minutes it takes him to go a mile. For the second half hour, we're going 7.5 minutes per mile. So we want to know, based off of this, what's the total distance that Howard runs each day. Probably the easiest way to do this is just figure out how far he runs during each of the half hours and add those together. So for this first half hour, that's 30 minutes, and it's 10 minutes for every mile. So 30 divided by 10 would give us 3 miles that he runs in that time period. He runs a little faster for this second half hour. Now we're doing 30 minutes divided by 7.5 minutes. And I just happen to know that 2 times 7.5 is 15, so 30 divided by that comes out to 4 miles. But you were allowed to use a calculator on this if you wanted. And then finally, the total will just be 3 plus 4, which is 7 miles. Choice B. For number 39, we've got parallel lines K and M intersected by lines P and Q, and we've got the measures of 2 of those angles on there. Ultimately, we're trying to figure out the value of this X degree angle over here. So in order to do this, we basically need to access something from this set of parallel lines. Now, the 40 and the 80, that's not really useful enough information for what we're trying to do here. It would be much more useful if we had this angle in here, which I'm going to label Y just so I have something to call it. If I could figure out Y, well, Y and X, those are alternate interior angles, so I know they're going to be congruent. So let's find the value of Y, and then we'll get X from that. So I know that 40, Y, and 80 are all on the same line. That means they all have to add up to 180 degrees. So I can write 40 plus Y plus 80 equals 180. So that's Y plus 120 equals 180. So that means that Y is going to have a value of 60. And again, since Y and X are alternate interior angles, that means X must also have a value of 60. So that's going to give us choice C. For number 40, we have a scatter plot right here showing weekly incomes in dollars for 15 individuals and years of higher education each individual completed. All right, so we basically want to figure out which of the following is the best line of best fit for this scatter plot here. Now, the key with line of best fit is that you're trying to get as close as possible to all the points. So you don't want to leave any points kind of hanging out there. So let's see if there's some that we can quickly eliminate. Choice A actually looks like a pretty good fit so far. Let's see if there's something better out there. Choice B, this one is kind of skewed toward the top of all the data, so B is not a good line of best fit. Choice C is kind of more central, so this one isn't too horrible. We'll keep this one in the running for now. Choice D is just way out there. You're missing all of this data down here. So I would say B and D right away, you can eliminate those, and we're just now picking between choices A and C. Now, between the 2 of them, A appears to be closer to more of the dots than C. If you look at C, there's these points down here that are kind of far out. Same with these ones up here. That's less of an issue with point A. I mean, you're still going to be kind of leaving some of these out, but A is closer to more of the dots than C is. So based off of that, A is going to be the best line of best fit that we can find in this problem. For number 41, we have a free response problem with a histogram that gives heights of students. We want to know how many students in Landon's class, that's who this is all based on, are at least 65 inches tall. So at least 65 inches tall, we are looking at the 65 to 60 category and also all the heights that are taller than that. So we essentially have to add together all of these bars from 65 onwards. So that is going to be 3 plus 5 plus 1 plus 2, and those all add up to 11. For part B, we want to know what fraction of the students in Landon's class are between 65 and 68 inches tall. So in order to get a fraction, you need a numerator and a denominator. In the numerator, we'll have the number of students who are 65 to 68 inches tall. In the denominator, we'll have, well, all of the students. So let's figure out all of the students first. We've got 6 plus 5 plus 3 plus 5 plus 1 plus 2. And we already saw that there were 11 students from 65 onward, so it's really just 11 plus 11, which comes out to 22. Next, the number of students between 65 and 68 inches, that's just going to be 3 plus 5, so 8. Our fraction then is just going to be 8 over 22, which we can reduce to 4/11. For number 41, part C, we want to know what could be the median height of the students in Landon's class. And the key word here is could, because we don't have exact measurements for anybody in here. So we're going to have to kind of give one of a number of possible correct answers for this. One way to find the median would be to basically write out all of the heights, but since they didn't give you exact heights, you would have to write out 61 to 62, 61 to 62, like 6 of those, 5 of these 63 to 64s, 3 of these 65 to 66s, and so on. And then you can cross off until you figure out, what the median range is. Another way to do this, then I'm going to show you here, is my little trick to find is to find the index number of the median student. So which is it? Is it student number 10 or 12 or whatever? So the way I do that is for 22 students, I'm going to add 22 plus 1. I'm going to add 1 to however many students there are, divide that by 2, and then if you just take the total number of items and add 1 and divide by 2, it always gives you the index number of the median. So this is 23 over 2, which comes out to 11.5, which is kind of weird to think of, but student number 11.5, if we go from left to right here, is going to have the median height. So where does 11.5 fall? Well, here's 6, here's another 5, bringing us up to 11, and our 12th student falls in the 65 to 66 range. So 11.5 falls exactly on the border of 63 to 64 and 65 to 66. So what does that mean? Well, we would average these together, but, again, we don't have exact numbers to average together, so how do we do this? I'm going to play it safe, and I'm going to average together the tallest student in the 63 to 64 range with the shortest possible student in the 65 to 66 range. So basically, I'm going to do 64 plus 65 over 2, which gives me 64.5. And that's guaranteed to be a median value. Now, they would have accepted other possible answers because we don't really know. I mean, maybe all of these 63 to 64 students are really just 63. And maybe all these ones over here are really just 66s, right? In which case, your median would actually be the same, but maybe they were all 65s instead. So there's definitely a lot of possible answers. You just need to pick either 63 or 64 and either 65 or 66 and average those together, and whatever the answer is, that's what they're going to take. For part D, will the new median height, if we add Landon's teacher's height to the data, and she's 65, will the new median height from doing this be less than, equal to, or greater than the median height you found in part C? Explain your reasoning. All right, so we're going to have to base our answer to this off of whatever we wrote in part C, which you'll recall for us, or for me anyway, was 64.5. So we're going to compare to 64.5. Now, if we add Landon's teacher in here, and she's 65 inches, that is adding a 23rd person to the data set. So that means the index number of our median now is going to fall at 23 plus 1 over 2, which is 24 over 2, which is now student or person number 12. Number 12, that's the index number of our median height. So where does 12 fall? Well, we still had 11 people here from 61 to 64, and our 12th person, even with Landon's teacher added in there, is falling in this 65 to 66 range. So that's what our median height is going to be, somewhere between 65 and 66. Now, since we're in that range, that is greater than what I answered in Part C. My Part C median, again, was 64.5, and anything from 65 to 66 is going to be greater than that. For 42, we have a small cube and a large cube, with edges represented as x and 3x. We also are told the small cube has a volume of 64. So based off of this, for Part A, we want the value of x. How do we get that? Well, we are given the volume, so let's use the volume formula. We know that volume equals s cubed based off of our formula sheet, or maybe you just knew that. So 64 then equals x cubed. To get x, we have to cube root both sides. So the cube root of 64, which is going to come out to 4. And that'll be 4 inches because they gave us units, so we have to give them units. For Part B, they want the surface area of the small cube. Surface area formula, based off our formula sheet, that's 6 times s squared. We already found s in Part A. It was 4. So that means we have 6 times 4 squared, 6 times 16, which comes out to 96. And our units on this, since it's surface area, that's going to be square inches. For Part C, the surface area of the large cube is how many times the surface area of the small cube. So for this, we need to figure out, there's a lot of ways of doing this. I'm just going to figure out the surface area of the large cube and then divide that by the surface area of the small cube. That's the most straightforward way to do it. But you could use these terms with x's in them and actually get an answer doing it that way. But I'm not going to be that fancy. So to get the large one, we need to do 3 times 4 to get this edge. We find that this has an edge of 12 for the large cube. So I'm going to do 6 times 12 squared now to get the surface area of the large cube. And I'll use the calculator for this. 6 times 12 squared comes out to 864. And now we're going to divide that by the surface area we just found, which was 96. Let me do that on the calculator. So dividing my answer that I just got by 96, I get 9. So that means that the large surface area is 9 times the small cube surface area. For part D, we want to know the volume of the large cube is how many times the volume of the small cube. So again, I'm just going to calculate the large volume. That's going to be 12 cubed, which, let's see what that is. On my calculator, that comes out to 1,728. And we already know the volume of the small cube. They told us that. It was 64. So then our large cube is going to have a volume that is 1,728 divided by 64 times the small cube's volume. And let's see what that actually comes out to on the calculator. Divide my answer I just got by 64. So that's going to be 27 times the volume of the small cube's volume.